Artificial intelligence is revolutionizing solar plant maintenance. By analyzing real-time data, it detects issues early, predicts failures, and ensures smooth operation. Predictive maintenance is key to optimizing solar plants. By detecting faults early, it prevents downtime and ensures continuous energy generation. IT reduces operation and maintenance costs by minimizing manual inspections and optimizing schedules. This approach also extends the life of equipment, addressing issues like hotspots before they cause long-term damage. By keeping panels and inverters performing at their best, efficiency is maximized. Facilitates the management of large, distributed systems through centralized monitoring. AI-driven inverter diagnostics bring a new level of intelligence to solar maintenance. Let us explore what it detects. Continuously monitoring key parameters like voltage, current, temperature, and efficiency ensures inverters are running at their best. Through learning normal behavior, AI can flag anomalies in real time, catching issues before they escalate. This predictive capability helps identify potential failures, reducing downtime and increasing reliability. With machine learning models and IoT sensors working together, data flows seamlessly, empowering smarter, more efficient solar systems. In solar plants, machine learning algorithms play a crucial role in fault prediction. Support vector machine classifies healthy and faulty behavior quickly, using historical data to make fast, binary decisions. Artificial neural networks go a step further, learning complex patterns to predict faults before they happen, allowing for proactive maintenance. XGBoost, a powerful boosting algorithm, enhances forecasting accuracy by learning from past errors, ensuring that predictions become more precise over time. Together, these algorithms create a more reliable, efficient, and cost-effective approach to maintaining solar systems. Thermographic defect detection uses infrared cameras to spot heat anomalies in solar panels and components. What does it detect? It detects hotspots from cracked or degraded cells, loose or corroded connections, shaded or soiled areas, and bypass diode failures. Let us see how it works. By capturing thermal images during operation, AI or experts analyze the data for potential faults. Once detected, the system flags issues for targeted maintenance, ensuring quick and precise repairs. Real-time solar asset monitoring ensures optimal performance by live monitoring of panels, inverter, battery, and other components. Real-time monitoring tracks power generation at the panel and string levels. It monitors key aspects such as system efficiency, performance ratios, battery health, and inverter status, ensuring everything runs smoothly. Environmental factors like irradiance and temperature are also tracked, helping to optimize energy generation and system reliability. At Green, we drive sustainability with innovative energy solutions. We empower progress, accelerate growth, and elevate lives.